Welcome, code aficionados and digital daredevils, to a podcast that's about to dive deep into the fascinating world of WebAssembly. WebAssembly, or Wasm for the initiated, is revolutionizing modern engineering, pushing the boundaries of what developers can do. It's like a secret portal connecting your code to the digital cosmos. On this show, our hosts, Joel Moses, Oscar Spencer, and Matthew Yakabuchi, will be your guides to this virtual dimension, decoding the mysteries and unveiling the endless possibilities. So strap in for a bite sized adventure as we take off with WebAssembly Unleashed.
All right. Thank you, Tabitha, and welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. As always, I'm your host, Joel Moses. Alongside me, my fellow creatures of code, denizens of disaster, and WebAssembly wildlings, Oscar Spencer and Matt Yakabuchi. I'm running out of things to call you guys. As you know, here on WebAssembly Unleashed, we always provide some perspective on proposals and changes and what updates mean to the WASM standard. And we ruminate on things that I guess need rumination. I'm super excited about our WASM community guests today, but first, let me introduce my compadres, Oscar and Matt. Hey, welcome, guys. How are you?
Hey, Joel. Hey, everybody.
It's a beautiful day in the world of WebAssembly, as always, Joel.
Excellent, excellent.
Yes.
What's been going on in the community that you're paying attention to these days, Oscar?
Yeah, I'd say the big thing, there's a number of cool proposals that are slowly, advancing through. The big one is stack switching. That's the one that I'm pretty excited about. And so there was the huge feud between the two different camps of where it was going to go, but the two proposals have merged into one. So the war has ended. But alas,
that's coroutines and WASM-FX, if I remember correctly. So
yeah.
it's advanced to phase 2, I guess.
Yeah, it's up to phase 2 now, which is pretty sweet.
That's awesome.
And beyond that, up and coming end of September is the WebAssembly Component Model Plumbers Summit. So for folks who are interested in things and people who are working on the component model and anything else happening around the world of WebAssembly, definitely check it out. It's going to be in Seattle for those who are local.
That's awesome. And Matt, got anything that you've been watching?
Just kind of like the higher level stuff, some of the more, journalistic attention that's being foisted on like WebAssembly these days. Like I'm seeing a lot of articles come out, a lot of developer focused articles and even production focused articles, which would lead us into the episode that we have today. But it's really starting to gain traction, not only from, these low-level engineering concerns, specification concerns, but it's starting to get some hype or some real traction.
Yeah, I've definitely seen an increased number of mentions, especially in the media, and it does seem to keep pace with the advanced rate that the phases seem to be going through that are happening inside the development community. So maybe one is driving the other. I'm not sure, but it's an exciting time to see things pulling together. I guess it's time to introduce our super special guest today. We've got Sal Cabrera, staff developer at Shopify. And for those who have been watching within the community, some of Sal's presentations he's given over the years, you're going to know that Shopify was an early adopter of WebAssembly, server-side WebAssembly in production, which is the best type of adoption. And he's also behind Javi, the JS to WebAssembly toolchain, and Winch, a WASM time baseline compiler. Welcome, Sal.
Hello, thanks for having me. I'm excited to be here today.
Great. Welcome. Let's jump right in. First, why don't you introduce yourself to our audience and kind of let folks know what you and your team are doing at Shopify with WebAssembly. Can you describe what you rely on WebAssembly for production use there?
Sure. So my name is Saul Cabrera, or Saul, that's either or, that's fine. I work at Shopify as a staff developer. I lead most of the WASM investments. And we use WebAssembly at Shopify for Shopify's extensibility. So essentially execution of untrusted third-party code. So the gist of the product is that if you want some business logic that Shopify doesn't really know about or doesn't really want to know about, you could upload some WASM module that we execute in order to enhance that particular business logic. The main example that we have for that is, what if you want to apply a discount in some that it's only applicable if you know about some special conditions that only are really applicable between the merchant and the buyer. Well, Shopify doesn't know anything about that. And then a developer can upload that Wasm module that has that logic and then outputs that discount.
Wow, modular pluggable functions. I can see why you and Oscar got together and have chatted at some of these conferences. Yeah, and I'm curious, what led you and your team to decide to use WebAssembly so early on in the server side space? It seemed really, really early to a lot of us that were watching.
Right. Yeah, that's a good question. So I think to answer that question, it's good to take a step back. The product that uses WebAssembly now, it's a product that existed before, but it lacked many of the characteristics that WebAssembly had, especially polyglot characteristics. So that was one of the first ones. It seemed very natural if you wanted to write these functions in multiple languages to use something like WebAssembly. And then the other one that it's not less important than the first one is security. Having to secure language runtime like Ruby or JavaScript or any of this, it's definitely more challenging if the security characteristics are not in the language specification itself, like in the case of WebAssembly. So I would say these two were the leading ones, and then also performance. There are many performance tricks that you can pull off when you're using Wasm due to its static nature. So yeah, I would say those are pretty much the three characteristics.
And I really want to underscore for folks like the level at which y'all are using WebAssembly in production. I believe at Wasm.io you gave a statistic, and maybe you can rattle off for me again here. But how many functions per second, like how many invocations happen over like a Black Friday, for example?
Yeah, so I'm blanking on the exact number, but it was a huge number. I think it was around, I don't know, maybe 100 million invocations per minute, something like that, during 4 days, sustained during the Black Friday weekend. So that's a lot.
Wow.
Yeah, so there's definitely considerable usage that's happening. So I think you can very easily say that it is stable and working in production.
Yeah, totally. It has been working great in the sense that we haven't had a single issue that we can point to say this is only WebAssembly related since we adopted it.
That's great.
And so you talked about trying to get something that was more polyglot, but you're the creator of Javi, and so it's sort of, I think this is really the pioneer of JavaScript in WebAssembly. And so how did you come to that decision? Who was the first person who said, "Oh yeah, that's a great idea. Let's roll with it"?
Well, I mean, actually, that's a bit ironic how all this ended up coming to be. The decision was mostly a forcing function of Shopify's users. So most of Shopify's stack is really JavaScript based when it comes to creating apps, right? So, but at the time, the popular languages for WebAssembly were systems programming languages. So basically C, C++, Rust, and at the time also AssemblyScript. But the feedback that we received regarding AssemblyScript is that it looks, but it doesn't really feels like TypeScript when you want to do some of the more higher level stuff. So I decided, well, there must be something else that we could do here. And I was very naive at the time in terms of, okay, this should be easy to do, right? But it was not that easy, but it ended up working. So was mostly a proof of concept to see if we could meet our performance SLOs, because that's the other thing with how we use Wasm. Our performance SLOs are really, really aggressive. We can talk about that if you want later. And then that seemed to work great for what we wanted to achieve, and then bring developer experience to a next level for people that are not familiar with these lower level languages.
That's pretty cool. Hey, Sal, I want to go back a little bit in time. I think at WebAssembly Summit 2021, you gave a production about production-ready server-side WebAssembly, and it was entitled "The Challenging Parts." And you drew a parallel there, an engineering parallel that I can't stop thinking about. Partly because I'm kind of an aviation geek, but also because it kind of resonated with me. You talked about the Concorde, and the Concorde was essentially a sea change in the way technology in that space was generated and how it was built. but that ultimately it never really found a footing because it wasn't really well designed for the actual task at hand. And you kind of compared that to the state of WebAssembly at the time, and you pointed out that there were some things missing. And I think that some of the things that you said were missing were some easy tracing and debuggability features. You talked about the importance of including some of those things, and you talked about the deficiencies in like guest host communications. From 2021 forward, what challenges still remain? Has everything been solved that you cared about towards Preview 2, or is there still something out there that would make it better for production use?
I think that many of the challenges still stand, but there is progress on those fronts. So I wouldn't say that things are stale in that sense. I think there is progress. What I see, something that's affecting that progress, or maybe not affecting, but something that we need to weigh in when we see progress, is that on top of making progress on the applications themselves, there needs to be progress on the standards also, which is something that takes time. But in the Bike Alliance specifically, I can talk about that there are many RFCs and many proposals that have been floated around in order how to improve debuggability for Wasm time, for example, which is our engine of choice, which is really incredible to see the community putting that as a priority and trying to move those things forward. So yeah, I think that the TLDR, or my takeaway here, is that there is great progress that is coming along, not necessarily finalized, but coming along.
So we're not designing the Concorde here, is what you're saying.
I think we're not. Yeah, I think we're doing better in a sense. Yeah.
Great.
What I love about this is this. What you're saying is one of the core, one of the core values that the WebAssembly community has been, purporting to give to us, like extensibility, like a common bytecode representation, so you can compile multiple languages or multiple representations of your logic into one consumable format. I mean, this is great. This is exactly what we expect to see. But going back to like that observability and some of those challenges there. So there's an observability specification that's open now. Is that meeting your needs, or are you seeing yourself having to build a little bit of the car as you're driving, a little bit of the Concorde, to go back to your analogy, as we're trying to fly across the ocean?
Yeah, so in the grand scheme of things, I think there is always the need to build something custom for the immediate need, because there's going to be always this sense that something is missing and that we cannot necessarily wait until we see the fully standardized final version of a particular feature. So the way we approach that is that we try to make sure to stay on top of how things are going to evolve, so that we don't go in a different direction than what it's going to be intended to. But yeah, that's totally a valid question. We build some things that are custom to how we use WebAssembly for our internal use case. Yeah.
If a developer is looking to use WebAssembly in production, what is the best piece of advice that you can give them that you wish someone had given you?
Great question. I'm not sure if this is specific to Shopify use case, but making sure that your SLOs are in line with how server-side WebAssembly works, at least with regards to how it works on the browser, for example. In the browser, there are several things that are given, quote unquote, like fast startup needs to be a thing that needs to exist from day zero, because you want pages to load fast. Sometimes there is this notion that in server-side WebAssembly, you might not need that because you can compile to machine code ahead of time, deploy your compiled code, and then just execute it.
Mm-hmm.
But there are some trade-offs when you try to do that. The more machine code you store, the bigger those blobs are, the harder they are to cache, to transfer.
Mm-hmm.
And so that model at the scale that we're operating in sometimes gets really, really challenging. And to the point that it might affect some of the SLOs that you had initially imagined with the near native speed of WebAssembly. So I would say analyzing those edge cases, depending on your scale, sometimes it's really, really important. Also, the security implications of storing machine code, Wasm engine version upgrades, and all that. I think those are things that we didn't observe when we started, and we thought, okay, this works great. But then, as soon as we started having, bunch of modules, we started seeing, well, this is going to be something that we need to address at some point in the future if we want to manage the scalability, or in the case of a security incident, how do you deal with all those things?
That's good advice.
So on that point, which is, in a quick aside, I've always pronounced it Javi, but I think it's actually pronounced JV. Is that official pronunciation, or have you sort of like bounced back and forth?
Well, we always call it Javi, so I think you're on track there.
Okay, I don't know what folks I've been talking to.
I think we need a pronunciation guide for some of the things in WebAssembly these days.
Yes,
Even Wazi.
Yeah, Wasm, Wasm. Yeah. Anyway, to the point that you were just making about figuring out like startup time. So a big part of Javi that makes it so good is the fact that it has Wiser like integrated in it, right? And so, like, is there a point in time at which using something like Wiser is going to be detrimental to your startup time? Because obviously, you've got this JavaScript runtime that's running inside of WebAssembly. That thing needs to boot up. You have user code. It's got to parse, tokenize, all the fun things to actually run the JavaScript bytecode. And with Wiser, we're able to pre-initialize the module, so we can do all of that work up front, store all of that data in the Wasm module's memory, and so it's completely ready to go. Have you seen issues with performance with that, or is it strictly just it's better?
We haven't seen any issues with that necessarily, but I think that's a combination of the fact that Javi uses QuickJS internally, and QuickJS startup is not it doesn't take as much time as other bigger engines like V8 or SpiderMonkey, for example. So one place where Wiser doesn't necessarily work for pre-initializing the engine, parsing and compiling to bytecode is if you want to have dynamically linkable modules. So Javi has this mode where you can just create a very, very small module that only contains the bytecode of your representing your JavaScript, and then you dynamically link against the module that contains a runtime. You cannot apply too much of the Wiser magic in this approach because your runtime lives in a totally different module and you don't want them combined. But again, I think this is not a drawback, just because how fast QuickJS is to start up. So yeah,
absolutely. So still kind of on that vein, can you tell me a little more about how you got to the point of saying we need winch? Like we're going to go modify Wasm time. Like, how did you get to that point, and how did you get leadership sign off on you spending time on that? Because that's what I want to know.
That makes sense. There are some variables here that that are some internal projects that we're looking into adopting WebAssembly, and one of them included like rendering HTML that needed to be compiled from a templating language to WebAssembly, and then from WebAssembly to machine code, and then you had to render the templates to the browser. So that approach is very natural to a browser for you to want fast startup. There were some cases in which the compilation time just took so long using an optimizing compiler like CraneLift, where we saw the need of, in order to improve the complexity of the infrastructure of that system, to have something that could render and compile in a very, very fast manner. And so that was one of the main use cases for Winch. And then the other use case, talking a bit more about Shopify Functions, which is a public project, is about simplifying the architecture that we had for Wasm time upgrades. So Wasm time upgrades, for many reasons, all of them valid in my opinion, do not guarantee backwards compatibility. So basically, if you upgrade, you need to recompile all your modules. And then there have been certain instances where that recompilation might take a long time. That means that we're in this weird state where we are serving with one version or the other, but you cannot always serve with the latest version. So being able to simplify um, all that architecture was another appealing characteristic to invest in something that could improve the compilation times. And then aside to that, we observed that for the modules that we were executing, the performance profile between crane lift and winch was not very far away, mostly because the modules have been previously optimized with something like Wasm opt. So the optimizations that crane lift was going to apply weren't that much, and so we weren't gaining that much from using something like crane lift. So,
And for the people who don't know anything about winch, can you explain what it is? Probably should have done that.
No, let's get into the details first,
Yeah.
then we'll come back.
I just dove right in. I apologize.
Yeah. So winch is a WebAssembly baseline compiler, and a baseline compiler is meant to compile from your source language to machine code really, really fast. This means that winch doesn't apply any optimizations to your source code. It basically grabs whatever WebAssembly you give it and lowers it to whatever backend you tell it to. Right now, there is the x86-64 backend is the most complete one, and we have partial implementation for ARM64. And so the winch has only one objective in life: is just compile as fast as possible so that code can be executed as fast as possible. So that I think that's a TLDR.
That's cool. So let's roll back to production use of some of these technologies. I'm really curious to hear what you would say now about some of the things that you had back then that you didn't have, that are different now. What exists in WebAssembly now that you wish you had been there when you first started down a production road? Is it component model? Is it something as basic as that?
Don't lead the witness, Joel.
That's a good question. Actually, I'm probably blanking a bit right now, but I'm seeing this mostly from the perspective of my work, in my day-to-day work. I think the many simple things that didn't exist then that exist today make at least my life incredibly easier now. For example, this is not WebAssembly specific. This might be engine specific, but engines have gotten at a point where you can explore what machine code is emitted from a particular WebAssembly module specifically. So I think Wasm has tools like this. I mean, this is the first one that comes to mind, but there are many other tools like this that you can use. For example, Wasm Tools has a wide range of tooling that you can use to inspect and work with WebAssembly modules that makes analyzing WebAssembly bytecode very, very easier than what it was before. This is incredibly useful because normal tools built for native targets don't have this, which makes it so debugging production issues way, way harder. What would happen back in the day is that we would receive a report that something is not working as expected, and we'll be given with a Wasm blob and then run with it. And it would be very challenging to just inspect it and try to understand what was going on under the hood. So I think the wide range of tooling that has been evolving for the server side use cases definitely is something worth highlighting.
Going into that a little bit more from another angle is, from the users, from the Shopify users, like what metrics do they get? And did you implement that from WebAssembly, or is that specifically on the host, or can you get into maybe some of the user experience or even the compromises that you had to make for users and observability and metrics and things of that nature?
Yeah. So in terms of observability, for example, the trade-offs that we had to make are not that much, I would say, mostly because how simple and hermetic functions are. So if you want to talk a bit about that, Given that these executions need to be extremely fast, and when I say extremely fast, is functions have a hard deadline of 5 milliseconds and around 11 million fuel instructions. Fuel instructions is not something that exists in Wasm generally. It's a concept used in Wasm time. Essentially, Wasm time counts all the WebAssembly instructions that have been executed for a particular program and then reports that to the host. And then the host decides what to do when that limit is reached. In the case of Shopify functions, that timeout is hit and then the execution gets canceled. And so given that these SLOs are enforced, and through WASI, we're able to basically block anything that can introduce side effects to the execution. So that makes it so that the execution is pure compute. So if developers want to analyze or observe what's happening inside, it's pretty much a pure function. So they can pretty much debug locally with a particular input and try to come up with fixes if there is an issue that they are having. I would say that those are the only two metrics that we expose to developers, and to be honest, they're probably the most important ones, aside from binary size, right? So I would say that to analyze binary size in languages like C++ or Rust, that's something that gets very challenging. There are tools like Twiggy, for example, for Wasm, in the case of Rust, that give you some meaningful information, but it's still the feedback that we have gotten is that it's not clear what to do after you get those reports. Like, how do you reduce binary size if Twiggy is reporting that a particular piece of Rust code is the one that is bloating your program? Right. So I would say metrics-wise, it's very simple. Then the challenge is, how do we make it so that easier for developers to understand what's the action that they need to take in order to meet the requirements that we have imposed for their programs?
Got it. So we have time for one last question, so I've got to ask this one. At the beginning of the talk, you started, you told us about why you chose WebAssembly for production use so early on. Leaving aside Polyglot, which I think WebAssembly really has no equal in terms of the technology space today, but thinking about like fast instantiation time and secure runtimes and things like that, there are other emergent technologies that are out there that could be used today. If you were restarting your work at Shopify today, would you still choose WebAssembly?
I think we would still do so. Leaving aside Polyglot, I think the security characteristic is one that's hard to beat. Having implemented a compiler, I can definitely say that the hardest pieces are being implemented in the engine in terms of how secure WebAssembly is, to ensure that you, as an embedder, you don't have to worry about it. So that's already a very hard lift, and a great feature that comes in when you're using WebAssembly.
Well, that's great. And that's reassuring to hear. That's unfortunately all the time we have today. Saul, thank you. Great discussion. Really encouraging for those of us who want to see more production use of WebAssembly. And always thank you to Oscar and Matt. It's a big application world out there. It's time to unleash the power and promise of WebAssembly. So for myself, for Matt, for Oscar, and for Saul, thanks for listening in, and be sure to subscribe for future WebAssembly news and views. Thanks, everyone.
That's a wrap for our WebAssembly adventure, fellow code explorers. Thanks for joining us. And until next time, may Wasm be with you.